Welcome to What I'm Reading, What I'm Thinking, where I share the research behind my upcoming book and how it's shaping the way I think about fascia, structure, and movement. Today, we're exploring something I see in almost every client I work with: shallow breathing. It shows up subtly: short inhales, limited rib motion, barely any diaphragm engagement, but it has powerful effects. To really understand what shallow breathing does to the body, we're going to look at something that might surprise you: breath-holding physiology. Specifically, the difference between holding your breath after an inhale versus an exhale, and the role of the Bohr effect, a chemical mechanism that governs how oxygen moves from your blood into your tissues. This isn't just about freediving. It's about how breathing volume and CO2 tolerance affect your posture, nervous system, and long-term health. Let's start with a core comparison. When you hold your breath after a full inhale, your lungs are full of oxygen-rich air. There's more volume to buffer rising CO2 and more oxygen available to delay hypoxia. This gives you a longer, easier breath hold. When you hold your breath after a full exhale, lung volume is much smaller, less oxygen, less room to handle CO2, and so blood gases shift quickly. Oxygen drops fast, CO2 rises fast. The urge to breathe comes on strong and early. Now here's the key: chronic shallow breathing mimics an exhale hold. Even though the person isn't holding their breath, they're spending their entire day in a low volume, low oxygen, CO2 sensitive state. Their system is running closer to a red zone, chemically and mechanically, without them even knowing it. Every breath you take affects your blood chemistry. In a healthy breath cycle, oxygen levels stay high, CO2 rises gently, and pH stays balanced. But in shallow breathers, oxygen input is limited, and CO2 is often expelled too quickly. Over time, this leads to a low CO2 state, a problem we often overlook. Why does that matter? Because CO2 is what moves oxygen from your blood into your tissues. Without enough CO2, the oxygen you inhale can't be delivered efficiently. This is the Bohr effect in action, and it gets blunted when shallow breathing becomes chronic. That means your muscles may fatigue faster, your brain may feel foggy, and your nervous system may stay in a low-grade state of tension, all because the gas exchange isn't working at the tissue level. Here's the science. The Bohr effect is the body's chemical handshake between CO2, pH, and oxygen delivery. As CO2 rises, it lowers the blood's pH. In response, hemoglobin, the protein that carries oxygen, releases that oxygen more easily into tissues. High CO2 equals better oxygen offloading. It's elegant and essential. But shallow breathers often hyperventilate without realizing it. They breathe frequently, but don't breathe deeply. That blows off CO2 and leaves the blood alkaline, making it harder for hemoglobin to release oxygen. So even if oxygen saturation looks fine, the tissues are starving. You can be oxygen rich in your lungs and blood, but oxygen poor in your muscles and brain. This is where structure and perception get tied in. Your respiratory drive is mostly regulated by CO2, not oxygen. CO2 tells your brain to breathe, but if you're constantly in a low CO2 state because of shallow breathing, your brain may become hypersensitive to even small CO2 increases. That leads to anxiety, air hunger, and dysfunctional breathing. Mechanically, shallow breathing reduces rib mobility, diaphragm range, and spinal dynamics. It limits fascial glide and shifts the whole thoraco-abdominal cavity into a compressed, defensive shape. Without full inhalation, you don't activate the lung stretch reflex. That calms the nervous system via vagus nerve input. Inhale breath holds benefit from this reflex. Shallow breathers miss out entirely. This is why I say shallow breathing is not just inefficient, it's a chemical stressor that reshapes your structure and perception from the inside out. So how do we use this knowledge? In clinical work, you can assess a client's breathing pattern and determine how close they live to an exhale-hold baseline. That changes how you approach their structural restrictions, energy levels, and even emotional reactivity. Breath retraining, with a focus on tolerance to CO2 and expansion of inhalation volume, restores chemical balance. You're not just improving breath, you're changing how their body delivers oxygen, regulates pressure, and interprets threat. Slow functional nose breathing and CO2 tolerance exercises all help recalibrate the system. You're not just building respiratory fitness, you're restoring metabolic and nervous system flexibility. If you work with fascia structure or nervous system regulation, the Bohr effect is part of your toolbox. It explains why a small change in breathing volume can lead to a cascade of effects, from muscle tone to posture to cognition. And it gives us a new lens to understand why breath work matters, not just for relaxation, but for gas exchange, pressure regulation, and restoring the body's adaptability. This is what I mean when I say breathing is structure. It's biochemistry, it's function, and it's perception. That's it for today's dive into the research and why shallow breathing is more than a bad habit. It's a chemical, structural, and sensory signal that something's out of balance. If you're enjoying this process and want to see how all these ideas come together, make sure to subscribe and stay tuned for the next one. There's a lot more coming.